Hey guys, Mr. Hussey here with Slope Intercept form applications. This should be a lesson for Monday, okay, the day after we did the live class on Thursday, and then no school Friday, so this should be Monday's lesson. Just want to start you guys off with a verse. Psalm 108, it says, "Give us aid against the enemy, for human help is worthless." I really love that, how they use the wording there. Human help is worthless. With God, we will gain the victory, and He will trample down our enemies. So just want to encourage you guys today that if you're struggling with something, remember human help to an extent is worthless, right? In some situations, it's worthless, especially if we don't put God first and ask for His help first. So just want to encourage you guys with that today. If you don't have the printout, could you take a minute? I'd like you to pause this video for a minute and write down these notes. These notes are important.
All I have is math.
Okay, so once you've written down those notes, what I'd like you to do is go ahead and we're going to go ahead and do these problems here together. Okay, so basically what it's saying is that if you have an initial starting value, okay, and you also have a constant rate of change, then you can model some of these word problems in what we call the slope-intercept form. Okay, so we'll have to refer back to these important parts here while we do our lesson today. So these four important parts I put right here. Okay, so if you're working off the sheet, then rate of change, that's M, initial value, that's B, independent variable, that's X, and dependent variable, that's Y. Okay, so let's look at number one. A computer repair shop charges a $25 fee in addition to $40 per hour to service a computer. Write an equation to represent the total cost to service a computer and identify your variables. Okay, so one of those two costs, either 25 or 40, is a reoccurring cost, and one is what we call a flat fee. Okay, the one that's a flat fee is this one. So $25 is a flat fee because they charge that $25 just for working on their computer at all, working on your computer at all. So if they do one tiny little thing to your computer, it's still costing you $25 because of their expertise. If they work on your computer for 10 hours straight, there's still a portion of the cost that's just $25. It's a $25 flat fee for working on your computer. Now, in addition to the flat fee, they also says, in addition, they charge $40 per hour. Okay, so say they just took a few minutes to do your computer, then they'd probably charge you this fee, and then they might also charge you for 1 hour, okay, because it's like part of 1 hour. If they took 2 hours to work on your computer, they would charge you this fee and then 2 of these fees. Okay, so 5 hours, they would charge you five of the hourly fees, so 5 times 40, and then they'd also charge you the 25. So that's basically what's happening here. Okay, so let's, on our separate paper here, let's put down number 1 if you're working on the separate paper, and what is the rate of change? Okay, so the rate of change, the way it changes here is this number 40. Okay, $40, because every change, the change here is in hours. So for A, our rate of change, what is the rate of change? That's $40 per hour, or $40 for every hour. That's the rate of change. All right, B, what is the initial value? That's the number we start with. So the very first number we start with, no matter what they do to your computer, if they even see your computer and do anything to it, that's $25. So the initial value is 25. What is the independent variable? Okay, the independent variable is the number of hours. Okay, and I'll get back to that in just a second. And then D, the dependent variable, is the cost. Okay, and here's why. Because the total cost depends on the number of hours, I'm going to call it, in the shop. So if you spent 1 hour in the shop, right, it would be, if your computer spent 1 hour in the shop, it would be like $40 plus that 25, right? So the cost would depend on that. If your computer spent 3 hours in the shop, right, so it'd be 3 times the 40, so 120, and then plus also that 25, so it'd be, what's that, 145. So the cost is the dependent variable because it depends on the other one. Okay, the hours don't depend on the cost because the hours could take 7 hours or 8 hours or 9 hours. The thing that's dependent in this case is the cost depends on how long it took. And if that's confusing to you, just keep saying it back and forth, and one of them is going to make more sense than the other. Okay, and you'll see as we go. So the other part we have to do here is we have to write an equation and identify our variables. Okay, so our variables is, if you go back up here to our notes, the number of hours we should probably write down. We should probably write down the words if you're working on separate papers so you can see this. The number of hours is your independent variable. The cost is your dependent variable, right? Because it depends on the number of hours you worked. So over here, let's write down our variables. Let's say let x equal the number of hours. And I'm just getting this x here because x is independent and my number of hours is independent. Right? And then let's say let y equals, you may have to pause this video if I'm going too fast and rewind. Let y equals the cost. Because y is the dependent variable and the cost we determined was the dependent variable. Okay. So if you do that, then your total cost is going to equal the $25 flat fee plus what? Well, plus 40 bucks for every hour you worked. So if the hours is X, let's make it like 40X, because if you worked for, if they worked on your computer for 1 hour, it'd be like 1 times 40. But if they worked on your computer for 5 hours, then it'd be 5 times 40. So your equation is going to be y equals 25 plus 40x. Okay, and a better way to write that would be y equals 40x plus 25. And that's your answer. Okay. These are components of your answer, so make sure you write these down. Now, the reason why I flipped it from this to this is simply so we can have it in that form, y equals mx plus b, which we've been talking about. That's called the slope-intercept form. Okay, so there's number one. All right, number two. All right, number two says, an online photo printing shop charges 15 cents per print in addition to a $2.95 shipping charge. Write an equation to model the total cost for printing pictures and identify your variables. Okay, so A says, what is the rate of change? So I'm going to write it down here so we're not confused. Rate of change. Okay, so in this case, is the rate of change, just zoom out here real quick. In this situation for number 2, is the rate of change 15 cents per print, or is it $2.95 per shipping charge? Okay, the rate of change is the 15 cents per print because that's the thing that changes based on how many prints you got. So if you got 2 prints, your cost changes, right? The rate of change. If you got 3 prints, your cost changes. The shipping charge is always the same. If they ship you 1 picture, it's going to be $2.95. If they ship you 10 pictures, they're still only going to charge you 1 shipping cost, okay? So the next thing we want to know is the initial value. Initial means like at the beginning. So what's your at the beginning value? Or what's the charge you're going to be charged no matter what? All right, that's $2.95 because no matter what, you're going to be charged for them to ship the prints. Whether they ship you 1 print or 100 prints, they're still going to charge you the shipping charge. Okay, C says what's the independent? And D says what's the dependent variable? Okay, you'll also hear these in science class, right? The independent variable and the dependent. I just think which one depends on the other one, okay? The thing that depends in this case is the total cost depends on the other aspects, okay? So the cost, or you can put the total cost, depends on the other aspects, like how many prints you buy, okay? So the other variable would be the independent variable, and in this case, that's the number of prints you buy, or just you could write prints, okay? That's the number of prints you buy, or just the prints, okay? All right, so if we go over here to the other part of our problem, we have to identify our variables, okay? So let's do just like we did on the last problem. Our independent variable, let x equal, and then our dependent variable let y equal. I always like to start with the dependent because that's easier for me to understand. So which one depends on the other one? Well, in this case, the thing that depends is the total cost. So let's let x equal, let y equal the total cost because that's my dependent variable. Y is our dependent variable up here in the notes. And then x would be the other thing that could vary, okay? So the other thing that could vary is the number of prints you buy. Okay, the number of prints could vary. You could buy 1 print, you could buy 10 prints, that can vary. All right, now, to write our equation, we want to say y equals, remember y is our total cost. Y has to be our flat fee. What's our flat fee in this case? What's the fee that won't change? Okay, so that's going to be the flat fee in this case is going to be our initial value, which is $2.95. Plus, and then that's going to be our, we're going to add that to the thing that can change. Okay, so that would be the number of prints times the cost per print. Okay, so the cost per print is 15 cents. Right? I'll put my dollar sign. The first time I put the cent sign here, but I'm going to put the dollar sign to make it like that. So 15 cents times the number of prints. That could be a P or an X. I'm just going to make it a P. Well, I'm going to make it an X because we're dealing with independent variables and dependent variables. Okay, so, and they want us to know that the independent variable is X and the dependent is Y. Okay, almost think of that like when you have an ordered pair X, Y, which one comes first? The X comes first, right? And whatever you have there, the Y could depend on that, right? The Y depends on whatever happened first, right? It's like called input. They call this one the input, and this one the output. Usually like when you have, you know, an XY table and you have something like this, y equals 3x minus 1. Usually what happens is they give you some x numbers, or if they don't give them to you, you start with the x numbers, right? So you might start with a -2, a 0, and say a 5. And then you take the x value, you plug it in, right? So 3 times the first one, 3 times -2 would be -6 minus 1 more. So the -7 that you find here depends on what you put in. So this one is dependent upon that one. That's why the y is what we call the dependent variable. The y depends on the x, okay? So if we come back here to this problem, the total cost depends on what happens here with like the number of prints you buy, okay? So that would be our answer. A better way to write it would be y equals 0.15x plus 2.95. Okay. And that will be your answer because we want it in the form of y equals mx plus b. Okay, now if you left the dollar signs on there, that's fine. For some reason, the teacher's notes took that off. Okay, I'm not really concerned about that part of it, but you would know that this would be if you threw in, say, like 35 prints, right? And you threw 35 in here and did the problem out, then you would know that the final answer is in money because we're dealing with money in this situation. Okay, so what I'd like you guys to do here is I would like you to try number 3 and 4. And if you'd like to try 5, you can too. 5 is the same thing. They just didn't set it up with the A, B, C, D for you. But 5, you're doing the same thing as on the front. So why don't you guys try 3, 4, and then you can also do 5 if you'd like. Okay, thanks a lot, guys.